Okay, greetings and salutations yet again. First off, I want you on your first sheet of paper, this is notes and examples, but these aren't really examples, it's to prove a point, okay? We have 6, we got 4. Remember, this sign here is greater than, and that other sign is less than, okay? Remember, it should always eat the bigger number, open up towards a bigger number. Now, I want to add 2 to both sides. Did the symbol change? So I'm going to put add 2. Well, that's 8, and that would be 6. Well, the sign wouldn't change. So when you add, it doesn't change. There's no change. Now go back to the 6 and the 4. Now subtract 2 from both sides. So subtract 2. Did the symbol change? Well, that's 4. And that would, 4 minus 2 is 2. I'm subtracting 2 from here and here. Okay, 4 is bigger. No change. So when you subtract, it never changes. Okay. Now, divide both of these by 2. Okay, so divide by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. Okay, and sign didn't change, so there's no change when we divided by 2. But now I want to divide by negative 2. Well, that's going to be negative 3, and that's negative 2. They'd be the same thing, but they'd be negative. Now negative 2 is bigger. So that one, there was a change. Okay, the sign did change. Now, whoops, I skipped one thing. Multiply both sides by 2. I skipped over the multiply by 2. I'm going to do it here. Multiply by 2. So that'd be 12 and 8. Again, no change from here to here. Okay. Okay, now multiply both sides by negative 2. Well, it'd be 12 and 8, but they'd go negative. Okay, so multiply by negative 2. So it'd be negative 12, and that'd be negative 8. Negative 8's now bigger, so the sign would flip. Okay, now there is a change. Okay, so it changed twice, when I divided by a negative and when I multiplied by a negative. Okay, remember that rule. Okay, now here's the first example. The product of a number n and 8 is at least 25. Okay, is at least. Okay, I'll write it down. Number n and 8 is at least 25. So I write 25 down, the last number. Is at least means it can go over the 25, okay? So I use the greater than or equal to, okay? Is at least 25. Now you got to put your variable, and the word I have in bold is product, okay? So n would be multiplied by number, it'd be multiplied by 8, okay? And that's all you do on that one, okay? The quotient of a number n and 12 is no more than 6. Okay, no more than. Now, no more than means you can't go over the 6, so it's 6 and then less than or equal to. So you put your n variable. And this time the word is quotient. Quotient means divide, so I underline the n and it'd be the quotient of n and 12. Okay, so those are my answers. Okay, so that's the first part. Now, next part, I would go to a different page. Now you're solving the inequality and graphing your solution if possible. Now you want to make your 8 boxes, but we're going to use 2 boxes this way for each problem. So we have negative 7x is less than 63. Now there's not one definitive answer here like there is with an equals. If that just said equals, I'd divide by negative 7 and have my answer. But with inequalities, with less than and greater than, we need to represent our answer with a number line because the answer is often infinite. It starts at a number and it goes either this way or this way, okay, to represent the possible solution sets. Okay, so there's a key thing you have to remember. It's like solving equations, but there's a key with an equals, but there's a key thing. Make a wall on the side of the x and find your x multiplying number, either your multiplier or divider. It has a multiplier and circle that multiplier. If that's negative, the sign is going to turn around, okay? If that 7's negative, I don't care about that number, it's about that negative 7. Okay, well I only have to do one thing, which is divide by negative 7. Okay? Those cancel, and I've got x on this side of the sign, but the sign then flips because I'm dividing by a negative, because there was a negative multiplier. 63 divided by negative 7 is negative 9. So negative 9 is your critical number, circle it. Now, it's opening up towards the x. I say eats x. Anytime it eats x, it goes this way. Okay? And then just put that answer up above. X greater than negative 9. Just put it up above on your number line. Okay, next one. Negative 12 less than or equal to 4x. So again, here's my x variable. Its multiplier is a positive 4, so it's a positive multiplier, so the sign will not change. Now I go divide both sides by 4. Now this time x is over here, so you need to place it over there when you fill out your answer. Negative 12 divided by 4 is negative 3. Now I know that's a less than sign, but, so negative 3 is a critical number, but it still eats x, okay? So that means x is actually any number. Whenever it eats x, it goes this way. I don't care what, okay? You can just put negative 3 less than or equal to x. Or you can put x and negative 3, but then the sign would turn around, okay? That'll work right there. Okay, next one. 14 minus 4x greater than or equal to 38. So number line is needed for all these. So it's x is on this side. Negative 4 is a multiplier because when it has a minus in front of it, that's plus negative, okay? And it has a negative multiplier, so that sign turns around. Now, before I worry about the negative 4, I need to get rid of the 14. So minus 14 minus 14. When you're adding and subtracting things outside the product or quotient, keep the sign the same. Don't go over here until after you've dealt with that coefficient. So it's 24 negative 4 dot x. Now divide by negative 4. And x is over here. Keep it where it's at. 24 divided by negative 4 is negative 6. So negative 6 is critical number. Fill in the circle this time because the line's there. And it eats the negative 6. So it doesn't eat x, okay? It eats a number. So anytime it eats the number we arrive at, then it goes this way, okay? So x less than or equal to negative 6. Okay, next one. We have 2. Sometimes I switch the variable in Algebra 2 from x to m. It's the same thing though, okay? Well, I need to get rid of my parentheses, so I apply the distributive property, okay? If you want to make that plus negative, you can. 2 times m is 2m. 2 times negative 3 is negative 6. Then I need to add the 7, less than 21. So my variable's m, its multiplying is by 2. So it's positive 2, the sign will stay the same then. Now you can do one of two things. I would combine these two on the outside. Negative 6 plus 7 is 1, so plus 1, and then we get rid of the plus 1 by subtracting it. That's how I would do it. So that's 22.m. So I divide by 2, and we have m on this side, and 20 divided by 2 is 10. So it eats 10, so it's got to go this way from the 10. Okay, it's always going to the left if it eats the number. Okay, so m less than 10, don't fill in the circle. And there we go. Okay, next one. Okay, negative 2 parentheses w plus 4 plus 9 less than negative 11. Alright, so I need again to apply the distributive property rainbows. That's negative 2w. Negative 2 plus times 4 is negative 8. You can either write minus 8 or plus negative 8. Plus 9 less than negative 11. Okay, w's over here. It has a negative multiplier, so whenever that multiplier is negative, you flip the sign. Okay. So again, I would combine these two on the outside. That's 1 plus 1, negative 8 plus 9, and then minus 1, minus 1. So we have negative 12 and then negative 2 times w. Now it's dividing time. So after I have divided by that coefficient, when I come over here, w's on this side, negative 12 divided by negative 2 is 6. So 6 is the critical number. Don't fill in the circle. It eats w. Okay? It eats the variable, so it goes this way. Okay? So w less than 6. Okay, next one. Negative 7 parentheses 3x minus 7 greater than or equal to 50 minus 21x. So again, I need to apply my distributive property. Okay, I would make that plus negative. Negative 7 times 3 is negative 21 with x. Negative 7 times negative 7 is plus 49. Then that's gone. There's nothing else over there other than that product. Okay. Then over here we have 50 minus 21x. Remember, that's a negative 21x. Now you have two different x variables on opposite sides. So we get rid of the smaller one, but there isn't a smaller one. They're the same. So you get rid of them. And you can ditch your number line. You ain't going to need that. Now it's either an all solution or a no solution. Does the sign eat the bigger number? Does it open up towards a bigger number? No, 50 is a bigger number. It should open up towards 50. 49 is not greater than 50. That's a no solution. Okay, NS. Next one, x, 3, and then greater than 15. So x is over here. It doesn't have a multiplier. It has a divider, so circle the divider. Okay, that's a positive divider, so the sign won't flip. I treat dividers the same way as multiplying. Okay, then I get rid of that 3 by multiplying by 3. Okay, because a divide by 3, multiply by 3 cancels, and then over here. So I have x by itself, and 15 times 3 is 45. So if you have a divider, you treat it like a multiplier. Just instead of dividing, you multiply to get rid of it. So I have 45, circle, eats the x, so it goes this way. Remember, if it eats the, I don't care what sign, if it's a greater than or less than, but if it eats our variable, it goes this way. The next one, x divided by negative 2, less than or equal to 6. Okay, again, x is on this side. It doesn't have a multiplier, it has a divider. So circle the divider. It's negative this time, so that sign flips. Nothing outside the divider, so we times by negative 2 and times by negative 2. So I'll have x by itself, or you could just multiply them. 6 times negative 2 is negative 12. Okay, so negative 12 is the starting point. Circle, fill it in, it eats the x. So we're going that way with it. Okay. Okay, now that is supposed to be a 10 right there. Sorry, I screwed it up on the document. So we have 2x plus 10 less or equal to 2x minus 8. Again, we have two different x variables, but they're on opposite sides, but they're identical, so we get rid of them. Number line's no good then. Becomes an all solution or no solution. 10's bigger, but it's not opening up towards 10, so that's no solution. If it does open up towards a bigger number, it's an all solution, AS. Okay, now, you see this next one. We have 3x greater than or equal to negative 12 and 8x less than or equal to 16. And it says and, okay? Now, when you have two separate signs, you see two signs, you want 4 boxes, okay? You want 4 boxes. We're going to do our number line. And now I'm going to make a table, okay? On one side, I just write 3x greater than or equal to negative 12. And on the other side, 8x less than or equal to 16. Okay. So now I solve two separate problems. On this side, the x is here. Has a positive multiplier, so at the very end down here, we're going to keep that sign the same. I can go right for the multiplier, so I divide by 3, and I have x. Negative 12 divided by 3 is negative 4. Now don't graph that yet because you have a different part. Okay, this time the x multiplier is a positive, so the sign will stay the same. And we can go right for that multiplier. Don't have to add or subtract. Divide by 8. Divide by 8. So we have x over here. 16 divided by 8 is 2. Okay, those are your critical numbers, negative 4 and 2. Okay, now circle the negative 4. It eats the x, so it goes this way. Circle, fill it in. Here it eats the 2, so it goes this way. Okay, they collide. Here's how you need to write it when they collide. They can either collide or go apart, either one. So I put x, just x one time. You put the negative 4 on this side and the 2. Now look over here. It eats the x and negative 4, it eats the x, so it's got to eat the x. X and 2, it's eating the 2, so just make sure it eats the 2. It eats the same thing, and there's my compound inequality. We did those last year quite a bit, okay? Okay, another compound inequality on the next one. 7x greater than negative 35 and 5x less than or equal to 30. Two separate ones, you make a table. On one side you put 7x greater than negative 35. On the other side 5x less than or equal to 30. Okay, so wall has a positive multiplier, so the sign stays the same, and I go ahead and divide that. Then I jump down here because now the x is by itself. And then I have negative 5. Okay, wall, positive multiplier, so the sign stays the same. And I undo the times 5 by dividing by 5, and now the x is isolated. So I have x and 6. So I have negative 5 and 6. Eats the x, goes this way. You want to fill in the 6, okay? Not the negative 5, but the 6. Here it eats a number, so it goes back the other way. Okay, they collide again, so x, negative 5, 6. So it's supposed to eat the x. Between the x and negative 5, it eats the x. So make sure it's eating the x. You don't keep it the same way because then it won't eat the x. It's got to eat the x. X and 6, it's got to be opening up towards a 6 with the equal sign. That's always how that's going to look. Both of these are going to end up being less than. Okay, when you have a compound inequality, like when they collide, okay, they're both less than. Noses both point the same way. Okay, next one. 3x greater than or equal to 3, or 9x less than 54. Or an and, don't worry about that. Okay, you're still going to go to your table. On one side, you're going to put 3x greater than or equal to 3. 9x less than 54. Okay, so over here, multiplier of 3, positive 3, so the sign stays the same. You don't have to add or subtract, you go right for division. And now the x is on that side by itself. And then 3 divided by 3 is 1. Okay, over here, multiplier of 9, positive, so the sign stays the same. No adding or subtracting, divided by 9. You got x, 54 divided by 9 is 6. So you have 1 and 6 are your boundaries. So 1, they can both be positive or both be negative, doesn't matter. Circle, fill in, each the x goes this way. Circle, fill in, it eats the 6, so it goes this way. Okay, so again, we got the same thing happening. So we put x, 1 on this side, 6 on this side. Remember, it opens up towards x. Between x and 1, it's got to open up towards x. What's it open up towards here? The 6 or the x opens up towards 6, so open it towards 6. Okay, and that's it. Okay. Okay, 9x less than or equal to negative 27, or 4x greater than or equal to 36. Again, you're going to make your table anytime you see those, it's two set signs. So on one side we got 9x less than or equal to negative 27. 4x greater than or equal to 36. Okay, we've got a multiplier of 9. 9's positive, the sign will stay the same. We don't add or subtract, we just go ahead and divide by our 9. Okay, sign stays the same. We have x on this side. Negative 27 divided by 9 is negative 3. So you have x, negative 3. Over here, 4 times x, okay, greater than or equal to 36. So you divide by your 4. Our sign won't change because that 4 is positive. You have x on this side, 36 divided by 4 is 9. So we have negative 3 on this side, 9 on this side. Each negative 3 eats a number on that one, so it's got to go this way. Circle it. Eats the x, so it goes this way. Now they go apart. When they go apart, you label them separately. You just copy these two and put them up there. Just copy it, okay? So x can go this way or this way. It's anything but in between. Okay, last one. Negative 12 less than 3x plus 6 less than 30. Guess what? There's still two signs, so you make a table. And we did this last year. But we don't have the or and. Well, you remember this. You do the overlapping circles. So on one side you put negative 12 less than 3x plus 6. On the other side you put 3x plus 6 less than 30. So if you got do the overlapping circles when you don't have and or, you're still using the table. Okay, x is over here, that's okay. Positive multiplier, so the positive multiplier of 3. So we minus 6. Minus 6. Negative 12 minus 6, negative 18. Over here you got 3 dot x. Now divide by 3, and your x is now doesn't have any operations, but put it this, drop it down. That's negative 6. Okay, over here again, 3 is still positive multiplier, so that sign's going to stay the same. We subtract 6. That's 24. 3 dot x. Now divide by 3, and your x has no more operations, so x goes here, 24 divided by 3 is 8. Okay, so I have negative 6 and 8. Circle, don't fill it. Opens up towards x, so we go this way. Opens up towards the number 8, so it goes this way from 8. Okay, so again, opening up towards x goes this way, opening to the number goes the other way. Now remember what we do when they collide into the same direction. When they go in the same direction, you put x, negative 6 and 8. Between these two, it has to open towards x. Between these two, it has to open up towards the number 8. Okay. All right, that's it.